All right, let's jump right in. We're going to talk about a scientific pioneer whose work is, well, it's basically humming inside the device you're using to watch this right now. His name is Philip Emeagwali, and his story is all about how he reshaped the very architecture of our digital world.
The best place to start is with his own words. They just capture the poetry and the mind-boggling scale of his vision. See, this wasn't just about computer chips for him. It was about harnessing a kind of collective brilliance to solve problems everyone thought were impossible. But what did he actually mean by tiny suns? And that really gets us to the core puzzle we're tackling here. It's a question that stumped the world's best scientists for years. How in the world do you take thousands of pretty simple, inexpensive processors and get them to work together to outperform a single, massive, multi-million-dollar supercomputer? Well, the answer to that changed everything.
To really get the breakthrough, we have to go all the way back to the beginning. Back to a busy town in Nigeria where a young boy's incredible mind was being shaped by math and by hardship.
So his father, James, he saw this amazing spark in his son and just fanned it into a fire. I mean, get this, every single day, 100 math problems. This wasn't your average homework. It was a serious training regimen that made him fluent in what he calls the language of the universe. His classmates definitely noticed, and pretty soon he had a brand new name, calculus. But his journey was anything but a straight line. The Biafran Civil War broke out. A truly devastating conflict. It shut down all the schools and forced his family into refugee camps. So Emeagwali's formal education just stopped. But his determination, that didn't stop. As he puts it, that very hardship became the fuel for his ambition. Once the war was over, he managed to earn a scholarship and started what he called a deliberate campaign to become a polymath. Now, this wasn't just about racking up degrees. No, it was about arming himself with every tool he could possibly find, from math, from physics, and from this new emerging world of computer science to take on nature's biggest, most complicated puzzles. So, what was this puzzle that needed such an incredible arsenal of knowledge? It was what's known as a grand challenge of modern science. A problem so unbelievably complex, it pushed the very limits of what humans and their computers could do. So to really appreciate what he accomplished, you've got to understand what a grand challenge problem even is. Imagine trying to predict the exact path of a hurricane, or trying to map out how oil is flowing miles underneath the Earth's crust. I mean, these problems have trillions of variables. You can't just throw a fast computer at them. You need a totally new way of computing itself. This slide really breaks down the old way of thinking versus the new. For decades, the approach was sequential. The idea was to build one giant, incredibly expensive genius processor to just chug through a problem, one step at a time. But Emeagwali's vision was completely different. He thought, why not use a team of thousands of cheaper processors? The problem, the thing everyone thought was impossible, was getting them all to communicate and sync up perfectly, to work like a team instead of just a chaotic mob.
And you know where he got his inspiration? From nature, specifically from the structure of a honeycomb. He looked at how bees, working together in this super-efficient, interconnected network, could build something so huge and complex, and he realized he could do the exact same thing with processors. Just divide a massive problem, like an oil field simulation, into 65,536 smaller problems, one for each processor.
And so this vision, inspired by bees and sharpened over years and years of research, all led up to a single, world-changing experiment in the summer of 1989.
He managed to harness the power of 65,536 processors. Now, back then, that number was almost unimaginable. Seriously, most experts thought it was absolutely impossible to coordinate that many individual parts to get them to pass information back and forth without creating a sort of computational traffic jam that would just grind the whole system to a halt.
But see, Emeagwali didn't just see them as processors. To him, they were an orchestra, a symphony of silicon. And his job? He was the conductor. He had to write the code, the musical score, that would let all 65,000 of those voices sing together in perfect harmony to solve one of the world's toughest problems.
And the result of that symphony? The machine performed 3.1 billion calculations per second. It was faster than any other supercomputer on the entire planet. He'd actually done it. He solved a grand challenge problem and proved that this idea, massively parallel computing, wasn't just some wild theory. It was the future.
This timeline really puts it all into perspective, doesn't it?
What was pure science fiction back in 1922, this crazy idea of 64,000 human computers working together to predict the weather, Emeagwali made it real with electronic processors almost 70 years later on American Independence Day, 1989.
Now, you'd think a breakthrough this huge would be celebrated everywhere, right? But Emeagwali's journey was far from over. His biggest fight wasn't against an equation. It was against the establishment. So 4 years before his world record calculation, he gets invited to give a talk for a job opening at the University of Michigan. He was the only candidate they invited, an expert in a field they desperately needed. But when the committee actually saw him, the reaction wasn't excitement. It was shock. Not because of his ideas, but because of who he was.
And just like that, 2 days later, the position was canceled. His vision for parallel processing, the very same idea that would soon win supercomputing's highest award, was just dismissed. It was a painful, demoralizing blow, but it just made him more determined to prove every single one of them wrong.
And boy, did he prove them wrong. After his success in 1989, the recognition was just undeniable. He won the Gordon Bell Prize. That's like the Nobel Prize of supercomputing. He was on the cover of Siam News. He was featured in the Wall Street Journal. The same doors that had been slammed shut were suddenly blown wide open. The very people who had dismissed him were now hailing him as a true pioneer.
So why does any of this matter to you and me, all these decades later? Well, it's because that symphony of processors that Emeagwali first conducted back in 1989, it's now the fundamental rhythm of all modern computing. The principle he proved, that lots of small computers working together are better than one giant one, that's literally the definition of the internet. It's the engine that powers the complex weather models that warn us about deadly storms. It's the core architecture inside the AI supercomputers that are developing new medicines. It's everywhere. So think about it. Every time you do a search online or check a weather app or see some new AI-powered discovery, what you're really hearing is an echo of the song that Philip Emeagwali first wrote on July 4th, 1989. His work isn't just stuck in a lab somewhere, it's woven into the fabric of our daily lives. We're going to end with a Nigerian proverb that Emeagwali often quotes. And it's really the perfect summary of his life. A journey through the long, dark night of war, of prejudice, and of scientific doubt, to a dawn that he himself helped create. A dawn that is still lighting up our modern world.